Well, thanks everybody for joining this presentation. But software cost estimation, we've already seen quite a bit about that. So I hope the topic is interesting enough for you to sit out another session on this. This is about the profession and also the initiative that NESMA and ICEAA have carried out the last couple of years, I would say, to create something that's called a software cost estimator at the certification. And I will show you a bit also about that. First, a bit about myself. A lot of you, I guess, already know me. I'm quite around already for quite some time. Over 25 years in IT, over 20 years in software measurement and metrics. ISBSG, I've been the president for a number of years, and now the past president. My actual job is IDC Metri, it's advisory, and there I'm the principal lead for IT intelligence services. I'm also a board member in NESMA, which probably you also know is a functional sizing measurement method, but also an organization that works with metrics and cost estimation. And the last one, ICEAA software, I'm going to talk a bit about later. They're my board member. About myself, I'd like to call myself 50 years young instead of old. Living in the Netherlands, Veendam in the north, and I'm married, 3 kids, and I have a lot of things next to software estimation and metrics that I'm passionate about. So that's all here. Okay, so today's topics, we're going to look at software cost estimation, of course. Why would we even do that? Going to look back a bit to the 2019 IT Confidence Conference, which was in Beijing. And because this topic was also then on the agenda, and I also presented there about this. Then about the ICEAA software special interest group, the certification program, and also how ISBSG data is used in cost estimation, also as part of the curriculum. Then some Q&A. Maybe there are some questions, I don't know, and maybe if we have time. Otherwise, I will have one final thought to share with you. Okay, so why would we even bother with software cost estimation? Well, it's very simple. Software projects often overrun, and we all know this. We all know these horror stories. We all know these things that are popping up in the newspapers. Systems that are overdue, schedule, money, everything. And often people give a lot of reasons why this happened. So the requirements may be unclear, maybe some setbacks in the project, but they never really talk about why or how about the estimate. Maybe the estimate was just way too low and could never be achieved. So that means that if you improve your estimate, at least you are going to make a better decision about should we do this? Is there a business case? Or maybe we should not do it. And then you're not really surprised with overruns in the end if it's more accurate, your estimate. So there are some laws out there which I think they're quite funny, I would say. So there's one that says, okay, 90% of the code accounts for the first 90% of the time, and then the remaining 10% of the code accounts for the other 90% of the development time. So that's of course not true, because that's mathematically wrong, but it gives the idea that people already in the project think they're already almost finished, and then they still have to do a lot of stuff. The Hofstetter here says, okay, it always takes longer than you expect, even if you take into account this law. And then Fred Brooks, of course, what one programmer can do in 1 month, 2 programmers can do in 2 months. It's also the mythical man month. I know a lot of you people here know about this quote and about this great book. But it's true, right? So these things happen in real life, and estimator should be aware of that, that these things happen. And yeah, you have to find a way to deal with this type of phenomena. So this is the estimation maturity model as constructed by Gallereth, and it shows just if you have a 0 level of maturity when it comes to software estimation, then you don't have a process, you don't really have a template, you don't really use tools, you just think of a number and say the number. While in level 5, you have formal sizing, you have a repeatable process, you have a robust parametric estimation, all kinds of measurement and analysis processes with tracking and control and continuous improvement. So you can make it, the process itself, a very mature one by just implementing these type of steps. But what do we see in the industry? We see that most of the projects in all across the industry are estimated using a maturity level 0 or 1 process. While it would be advised to have a more mature estimation process, because then, okay, it will take some more time, it will take some effort to invest in it. You need the experts, you need the data, etc. But then you won't have those big software project overruns anymore. So the issue is that the level 0 and the level 1 estimates are done by human experts usually. So you ask a guy, okay, how much do you think this will cost? And then he will give you an answer. That's your estimate. But humans are very optimistic always. And that's why the estimates done on level 0 or 1 are very optimistic ones. Parametric estimates, they are based on size, data, models. They can also be optimistic, they can also be pessimistic, but at least there is some logic behind it, and it's possible to understand where a certain estimate comes from. You can demonstrate it. The industry, however, nowadays, many organizations have moved to agile ways of working. And here you see probably a planning session where a lot of people use a lot of colored notes just to figure out, okay, what are we going to do the next sprint, the next PI even. And they often use the thing that you see there on the right, the story points method. Which I think is good for teams just to commit to some backlog items that they're going to produce in the next sprint. But you can also see here, for instance, it's a kind of a Fibonacci range. And this means that you can't really calculate with these type of numbers because it's not a ratio scale. So you can't get 4, for instance. And the problem is a lot of organizations do rely on story point metrics when it comes to also forecasting of and estimation of the team. And that's something that is really not possible if you think about it. So human estimation methods tend to miss the target, and therefore, okay, you can use them, but our advice, or my advice would be, okay, use at least also parametric estimation. And with parametric estimation, I will show you that in a minute, then you can become more realistic. So this is a great figure from the book from Steve McConnell. It's referenced there on the low right corner. And it shows that if you have a realistic estimate, your additional cost will be about 0% because the true will be very close to your realistic estimate. But if it's low, so the human judgment methods, they are usually low, your extra cost will go up because at some point you will realize you are not going to make it. You will get all kinds of problems in your project. You will even put maybe more people to your team, which makes it more expensive and usually not more faster. You introduce stress, you get more defects, you get lower maintainability in the end. All kinds of things happen there, and your cost will go up in a non-linear way. Well, on the right, you have high estimates, which are also not good, of course, but at least they are predictable because that money will probably be spent. It's the law of Parkinson that just shows that if you get some extra time or budget to fulfill some task, you will probably use it, make it a bit better, document a little more, and things like that. So if we look at the estimates, then you see that the human estimates are here, and the realistic estimates, the parametric estimates, level 2 to 5 maturity level, probably end up somewhere there, if everything is okay. Okay, then here you see me presenting at the 2019 Beijing IT Confidence Conference. And you see also on the screen something about cost estimator do exist, and I have the same picture, I think, also in this presentation. Because I was telling them, okay, we have cost estimation estimators in the industry. They get a pay, quite a good pay. Of course, there are all kinds of requirements that you have to be certified to be a cost estimator. And these people are very good in estimating all kinds of stuff except software. So cost estimators can easily estimate how much it costs to build a new highway or a new production plant, but not the software part of it, because that's something that you can't touch. And here you see the cost estimator, the flyer that I took there. And you see, we are trying to make the software cost estimator, making sure that there's also a profession out there that is capable of producing the right software cost estimates. So to complement the cost estimators that are already out there. And by doing so, we hope that this green line, the challenged projects will go up, and the red line and the yellow line, the challenged and the failed projects will go down. Of course, it's still a long way to go, but this is something that we are dreaming about. Now, to introduce the NESMA and ICEAA CEBoK-S, the cost estimation body of knowledge for software, and the certification. As you may know, NESMA is the functional sizing standard, but it does more. So one of the slogans is also NESMA more than just points, because everybody always identifies NESMA as one of the functional sizing standards, which is true, but it does much more than that. And here you can also see on the right that there was a CEBoK-S training and certification session not too long ago. So that's also that we're doing. I think a lot of people here on the call know what NESMA is. But ICEAA may be a bit less known because this is mainly a US organization. It's the International Cost Estimation and Analysis Association. And you see here just a screenshot of their website. You see also here on the left the new CEBoK-S, the cost estimation body of knowledge for software, that it's new and that we have certification of that. Because ICEAA, it was a cost estimation organization, so a lot of their members that come there are certified cost estimators from Boeing, from NASA, from all kinds of US military, Air Force, all those kind of big organizations with really rigorous estimation policies and procedures. And the software part always is a problem there. So ICEAA also thought this was a good addition to their curriculum. So here you see the ICEAA CEBoK-S. I'm not going to through all of this because, okay, you can, if you're interested, you can go to the site. You can also look at the short videos there. So I'll skip this one. This is how the training and the materials look like. So we have the CEBoK-S. We have all kinds of lessons about software development paradigms, right? So how do you estimate a waterfall project or an agile project or a spiral project or any other type of project? Software sustainment, of course, it's the largest part of the whole life cycle of an application is the maintenance. So that's what they call sustainment. Custom software development, the 5-step estimation process, the procured software solutions, right? So if you buy SAP and you have also to configure it and you have to add a lot of custom-made ABAP to it, those type of things are also covered. And then there are a couple of lessons about size, productivity, and commercial estimation models that are out there. And basically, if you learn all this, you can get the same thing that I have, the software cost estimation certification. And at the moment, there are not many people out there that have this certification, but that's just because it's just new. So we are now also at NESMA trying to set up some more training, some more certification exams, and a couple of people in the Dutch tax office, for instance, already have it now. All right, then let's have a look how ISBSG fits into all this. So ISBSG is, of course, has the repositories about data, and data is something you have to use when you use parametric models, just to fine tune the models to the situation that you're estimating. And ISBSG, if you don't know, probably it's has been touched earlier today. It's independent, not-for-profit. We have full members, where NESMA is also there, ISBSG, FISMA, and a couple of other ones, IFPUC. And there are two repositories, and we just released the new version of the repository that has 11,800 projects, releases and sprints in the development and enhancements, and 1900 plus applications in the maintenance and support. The nice thing is that if you have data and you use function points, for instance, you can always submit your data. We have the questionnaires. Luigi already showed a couple of those in the presentation. And if you do that, you will get a benchmark report in return. So these are a couple of examples of what you get for your productivity, for your delivery speed, etc., defect density, those type of things. And the mission of ISBSG is to improve basically the decision-making power of people in the industry. So we provide data so that the better decisions can be made regarding, for instance, estimation. And it's pretty unique because the data is all standardized, verified, recent. Well, recent it was not all the data is recent because ISBSG already exists 25 years. So we have also the data of 25 years ago still there. But we also have a lot of newer data. Even 2023 data is in the new repository. How does it look like? Well, I think we've seen already some examples here. I also have an example here, and one of the most important fields I highlighted here is the PDR, which is the inverse of the productivity, right? So the PDR is the project delivery rate. It's the hours per function point. So the number of function points per day would be the productivity calculation as it is universally defined. But PDR is the inverse of that because humans are usually can usually deal better with these type of numbers, 3.3 or 21.4, than something that's very small, like 0.0034 or something like that. So that's why we call it the project delivery rate. And it's a very important part of your estimation because, very simply said, your size times the likely project delivery rate will be your likely estimate for the effort. So just to show you a small example, we have here the selection, right? So you have you get the data also in this format, so in the Excel format. So you can simply put a filter there or pivot, and you make a selection that equal to ARB, year of project after some year, project type enhancement, Java in this case, and we count NESMA and IFPUC. Together we can use it because they're very similar in producing results. And then you can get a data set, 166 projects. You put some descriptive statistics there. And I usually use the percentile 25, the median, and the 75 to create a range of projects where I think, okay, this is probably a landing zone where I can work with. This is a simple example. Okay, we have here 1,000 function points, so we can easily calculate with these metrics what is going to be the range. And then if you put it on this figure, then this would be your landing zone, your 6,800, 7,800 likely, and 9,400 max. So usually what you would communicate in these type of things would be 7,000, 8,000, and maybe 10,000, because then you round it to a number and you don't claim to be too accurate, because this is still high level estimation, of course. But this shows you very simple, in a very simple way how the ISBSG data can be used. And this is also the type of things that are in the CEBoK-S that you can learn when you are doing that training and exam. All right. Well, I hope that I was a bit faster than expected because we were running behind, I think. At this point, I think I would like to answer some questions if there are any.
Harold, it's very interesting with the estimation and the work that ICEAA with producing the CEBoK-S.
Yeah, and I was personally the one who started it together with Brian Glosser, and we already talked about it in 2012 conference, and we worked on it with a group of people, with a large group of people, and it only was finished, I think, yeah, beginning of this year. So I think it can still be better, and we're going to improve it. But for now, it's pretty good. And yeah, so it was a long process, but I'm very happy it's here now, and that we can help the industry with better software cost estimates. Also, to recognize the people who are doing this work. Because if you have the certificate, you can show it, and you can show it to your boss to ask for a raise, but you can also tell people, okay, I'm a professional software cost estimator. I'm not something that just, not someone who just calls out a number when you ask me how much will it cost.
Yeah, looking at all the projects that have failed, it's really a need for this profession.
Yeah.
And, so it will be very interesting to follow and see people that are starting being certified and using their skills in project estimation. I only got one comment from Colin. Great presentation. Thank you, Harold.
Okay, you're welcome. Yeah. All right. I just have one final thought to share. So we want, of course, this to happen. All arrows in the yellow zone. So we want the estimates to be correct, accurate. Of course, always something can happen, but at least the estimate should not be the cause of the problems. And then this is really going to be the dream come true, and we want the green line to go up. And I would like to ask every one of you, if you want to be a professional software cost estimator, then please sign up for this training and do the certification, and then industry will be a better place. All right, thank you for your attention.
I agree, and thanks a lot, Harold.